Alright, in the last video we did a little bit of condensing the properties of logarithms in reverse. So first we expanded them and then we condensed them. I've already done a little bit of this, but we're also going to look at the end at something called the change of base formula, and I'll tell you more of the story there about that in just a minute. Okay, so I think it's easier than just trying to go step by step. I'm just going to talk you through. This is plus, so these two guys are going to be multiplied, and they're on the top. This -3, wait, I may have already done this exact same one in the last video. I think I did. This -3, the negative's going to put it on the bottom, and the 3 is going to be an exponent. So yeah, I'm pretty sure I already did this exact same one, but I'll just do it again. So here's what I would get. So that's a 1/2 exponent is going to turn into a square root in just a minute. Now this negative is going to put this on the bottom with the third power. Do you see? So if I put this back as an exponent, it's going to be to the third power, but the negative is going to put it on the bottom. And now we just have some cleaning up to do. This 1/2 is a square root. And on the bottom we have a power to a power. And that would be to the 6th. That was a terrible line. Okay. Okay, I don't believe I did this one, so if you want to pause and try it, that would be great. Well, I don't know, maybe I did do this one. So here's what I would see. I would have 5, and I'm going to do x to the 1/2. Now this is going to, I would do it with exponents. If you remember the last video, I'm going to make this a -1, so he's going to be like a 7x minus 1 on the bottom, because he's a -1. And then here this is going to be x minus 1 to the third. Because it was a plus, he's going to be on the top. So I have this. Now I have just one final step. I don't want fractional exponents here. I want you to see that those are roots. So I've got this. Okay, so let's try this one more time. Same stuff here. We're just going to see this is going to go to the bottom because it's negative, and it's going to have to the 4th power. Oh, that's a very strange looking exponent. But so here's what we've got. I have x to the 2nd. This 3x plus 5 is going to go to the top with a 1/x exponent. Isn't that strange? Now here, because it was a negative, it's going to go to the bottom. Do you see how this is going to become x plus 5 to the 4th power? So I put that back as an exponent, and because it was negative, it's going to the bottom. And now this was all a log. And now there's nothing I can do with a 1/x exponent. I am all finished. They did something a little different, but I don't think that's necessary. Yeah, it's the same thing. Okay. Okay, now very confusing one here. I think there's a couple ways you could do this. If I were looking at this, the first thing I think I would do is I would send this 4 through. I would distribute it and make it 12 log of x plus 4 log of x plus 5 minus 4 log of 2x plus 3. So I've just distributed that 4. Now we're going to do all the same things. I'm going to put everything back. These are positives, so it's going back as an exponent, but they're both positive, so they're going to be on top. So I'm going to have x to the 12th, x plus 5 to the 4th. Now this is going to be a 4th power, but it's a negative, so it will be on the bottom. And so I have this. And you always want to check to see if anything cleans up or can cancel, but here there's nothing. I mean, you could do some ridiculous amount of multiplying, but that would not be all that helpful. So there we go. Okay, now I'm going to walk you through this one. I was just looking at this before I started the video, and this is not a problem I've ever seen before, and I'm not really quite sure. I mean, they're just looking for an application of the laws of logs, and it's a pretty obscure one. But so what they're saying is this is our original formula for pH. Hydrogen ions, don't know much about that, but so they're going to say we're going to double it. So here's our original concentration, and now we've doubled it. But what they're going to do here is they're going to use the law of logs, which says if it's a product being inside of there, I could turn it into addition, And now what they do is they just distribute that minus. So they've used the product rule with logs to expand this. So they're saying, well, what happens if you double it? Well, look here. This is the original concentration, because that's the original formula. And then this is an amount that we're subtracting away. So all of this is the original formula. They just flipped it around. Here's the original formula, and we're taking away log of 2. So again, I don't know much about this, but what their point is, if you use the law of logs, you could prove mathematically that when you double the hydrogen ions, the pH is decreasing by the log of 2. Now this is the same exact thing. So it's negative log, but this time they're saying, well, what if we cut it in half and we had 1/2 that initial concentration? We would do the same trick where we could turn it into, well, I should do it like this. So I split that up because of the product rule of logs. Now I can distribute that negative sign. So what do we have here? Well, this is the original concentration. That's what it is. So that's the original concentration, and now it's decreasing by the log of 1/2. So I don't know what that number is, but so basically the same idea as it was before. Okay, again, never used that in my life, probably never will, but there it is. Okay, so our final idea here is the change base formula, and it's got a little bit of a story. So yeah, let's look at the one they've got here. Log 5 to the third of 3. So what happened with logs is that logs are an exponent, but a long time ago, a student would have a table of logs, and they might know 2 different versions. They would certainly know the common log. Remember, a common log was a log base 10. So they could memorize one chart and know all the logs for base 10. Or if it wasn't a memorization in a table, what would happen is the most basic calculators have a log button. And when the log doesn't say anything, it doesn't show the base, it is a common log. It is a log base 10. So although your fancy calculator now can just convert this to any base, the change of base formula was a trick that we could convert something from a log that we didn't know anything about, like log base 5, for instance, and we can convert it into to use the common log to solve it. So it actually works with the common log or the natural log. But so here's what I mean. It's very simple. Log base 5 of 3, you can turn it into the log of 3 over the log of 5. That's it every time. You just do the common log of the top divided by the common log of the base. You crunch these on your calculator. Make sure you do the log of the top and the bottom. You crunch these numbers on your calculator and you will get the answer to a log that would have been difficult to compute. Again, today technology doesn't make this all that difficult, but it was a trick back in the old days. It works to change base both into common log, or you could have changed it into a natural log. That's also a button that's commonly on a calculator, and it would do the same thing. It would work in the same fashion. Now, you really are supposed, let's see if they actually did it. No, they didn't either. So typically, like if I was asking this on the test, I'd want you to show this and then actually crunch these numbers on your calculator. But they didn't, because I'm not going to either because I don't have the calculator in front of me. But so if I were trying to turn this into natural logs, I can change it by making it the natural log of 8 divided by the natural log of that base of 0.5. It would make the computation much easier to do. Okay, now they're asking us to do it with a calculator, so I guess we're being asked to do it into a common log. So we're going from base 2 into the common log, and we would just crunch these numbers on our calculator. It turns out to be about 3.3. Now they did natural log, but it doesn't matter. If you either base, common log or natural log, you'll still get the same solution. Okay, so I'll do natural log this time, but it doesn't matter. That's all there is to it. Natural log of 100 divided by the natural log of the base, and you've changed the base into natural log. And again, common log would do the same. Okay, I hope that makes sense. It's pretty much, other than the change of base formula, which is very easy, it's pretty much what we did in the last video.